At assignment 42, we're going to talk about driving safety data, and specifically some distance numbers or distance data, specifically reaction distance. Okay, that's the reaction time, the distance the car travels once a person realizes they need to stop or that there's a hazard. The distance a car travels while braking to a complete stop is the braking distance. We're going to talk about some of that data because that's important. Sometimes you come across a hazard and you need to stop, or something in the road that you need to stop. And so we're going to talk about reaction distance, reaction time, brake distance, things like that. What is the reaction distance for a car traveling approximately 48 miles per hour? The reaction distance is the approximate distance covered in time it takes an average driver to switch from the gas pedal to the brake pedal. So that's what reaction distance is. The time it takes your brain to realize you need to apply the brakes, and the time that it takes for you to take your foot off the gas and apply the brake. That's the reaction distance. Research has determined that the average driver takes from 0.75 to 1.5 seconds to react. So somewhere just under a second to a second and a half to move your foot from the gas to the brake. A car traveling at 55 miles an hour travels about 81 feet per second. Okay, so you're traveling at 55 miles per hour, which is about 81 feet per second. If we're trying to find the reaction distance, then you can set up a proportion. So 81 feet in 1 second is equal to how many feet in 0.75 seconds if we're using the 0.75 number. So you just set up a proportion and you cross multiply. So 81 feet in 1 second is how many feet in 0.75 seconds. So if you cross multiply, you're going to end up with this. So the distance traveled, the reaction distance, the distance traveled, is almost 61 feet. If you're going 55 miles an hour, the distance traveled just to remove your foot from the gas and apply the brake is almost 61 feet. Okay? Now that's using the 0.75. If you use the 1.5, you just change that 0.75 to 1.5, you cross multiply, and that would give you 121 feet. So that's if your reaction time is a little bit slower, you're looking at 120 feet. So it's somewhere between 61 and 122 feet. That's the average. A conservative rule of thumb for the reaction distance. Now we're going to be talking about different distances, and this one is the reaction distance from the gas to the brake is approximately 1 foot every mile per hour you're going. So if you're going 30 miles an hour, it's 30 feet. If you're going 60 miles an hour, it's 60 feet. So therefore you can kind of, it's just an estimate. You can round it and say, well, if it's traveling 48 miles an hour, it's going to take about 48 feet. So if you get a question like this, a car traveling at 65 miles an hour, approximately how far will it travel during the average reaction time? It would travel about 65 feet. 1 foot for every mile per hour. That's not really difficult. What's the approximate braking distance for a car traveling 48 miles an hour? Braking distance is the time that it takes for you to come to a complete stop. The general formula for the braking distance is this right here. Your speed to the second power divided by 20. It's just a formula. So easy enough, you just take your speed and you plug it in for S. So 48 to the second power, because we're talking about 48 miles an hour, 48 to the second power divided by 20. So you just square 48, divide that by 20, and you get 115.2. So once the brakes are applied, on average, a car traveling at 48 miles an hour come to a complete stop after 115.2 feet. Okay. This question, this is not really a math problem, but what factors also need to be taken into account that might add to or subtract from your braking distance? So think about that. What's some things that might be taken into account that would affect your braking distance. Condition of the roads. Maybe it was raining or snowing. You guys have probably never driven on ice, but I can tell you that it's not fun. Tire pressure. If your tires are running low, then that's going to affect your speed and your miles per gallon. If you're impaired, that's going to affect your reaction time. So different things that could affect it. Okay, so this was braking distance. The other one was reaction time. So Rachel's driving 48 miles on a one-lane highway. She sees an accident directly ahead of her about 200 feet away. Will she be able to stop in time? So now we're talking about total stopping distance. The total stopping distance, think about it. First, you have your reaction time. So you have to realize that you need to take your foot off the gas and put it on the brake. So there's your reaction time. And then once you put your foot on the brake, then there's the braking distance, how long it takes for you to come to a complete stop. So if you just add those two, that gives you your total stopping distance. So Rachel's total stopping distance would be this number, 115.2. That was the braking distance. And also the 48, the reaction time. So if you add those two together, her total stopping distance would be 163.2. So let's work one like that. What's the total stopping distance if you're traveling at 65 miles an hour? So you're going to take this braking distance formula. You're going to add to that your reaction time, which is going to just be the 65. And whatever we come up with there, that's going to be our answer. So S squared over 2, that's your speed, which is 65. So 65 squared divided by 20 is 211.25. Then add your reaction time, and you get 276.25 feet. All right, last one. Desiree is traveling through Canada. The speedometer in her rented car indicates kilometers per hour, and all of the road signs give distances in kilometers. She knows that 1 kilometer is equal to 1,000 meters, and 1 meter is a little more than 3 feet. Determine Desiree's total stopping distance if she is traveling at 88 kilometers per hour. Well, we're going to skip through this because what they have given us is if you're given meters, then your total stopping distance in meters is this formula here. Your speed to the second power divided by 170 plus your speed divided by 5. So if she's traveling at 88 kilometers per hour, right there, she's traveling 88 kilometers per hour. So we can find her distance in meters by using this formula. So you plug in the 88 squared divided by 170. This is just a new formula. So if you're given kilometers per hour and you want to find how many meters it's going to take, then this is the formula. So your speed to the second divided by 170 plus your speed divided by 5. Let your calculator do the work. And if you square that, divide it, and then add it to this, you're going to get 63.15 meters. So that's going to be a good answer. That's how many meters. And if a meter is a little more than 3 feet, if you want to know how many feet, just multiply that times 3. Okay. Let's do this problem here. A car is traveling at 78 kilometers per hour. What's the total stopping distance in meters? So we're going to go back to this formula. So the speed divided by 170, the speed to the second power divided by 170 plus the speed over 5, which was 78. So 78 squared over 170 plus 78 over 5. And just let your calculator do the work. So 78 to the second power divided by 170 is 35.78823.529 plus, and I'm going to do this. Notice I did not round. This is 15.6. Add these two together, 35.78823.529 is equal to 51.3, and it says round to the nearest hundredth of a meter, which means I'm going two places. So 51.38, and I'm going to cut it off right there, but this 8 will push that one up to a 9, so 51.39. So the answer would be 51.39 meters. Okay, that's assignment 42.